Now I have to discuss the questions. State and prove the properties of probability distribution function of a random variable x. Second question, random variable x is probability shown in the table. Find the value of k. Find fx of x, fx of small x, and draw the plots. Probability of x is equal to minus 3, minus 2, minus 1, 0, 1, 2, 0.2, 0.5 k, k, 0.1, 0.3 k, k. Now define the question. Define the explain probability density function PDF and probability distribution function PDF for Gaussian function or normal density function. Explain Rayleigh probability density function and Rayleigh distribution function, how the maximum value will be occurred and its applications. In an experiment, there are two boxes. Each box contains ball as shown in the table 2.4. The event is to select a box randomly and select ball from the selected box. If the probability of selecting the first box is 0.3, then find conditional probability distribution and density function. Now probability distribution and density function and plot the functions. Details of the balls in the two boxes. Those are ball colors red, blue, white. Totally total of the balls is 10, 20, 50, total 80, 50, 40, 30, total 120, 60, 60 and 80, 20. A Gaussian random variable x with u of x is equal to 4 and g of x is equal to 3 is generated. Find the probability of x less than or equal to 7.74 with written down function and draw the plot graph. And similarly, the lifetime of system expressed in the weeks is Rayleigh random variable x from which f of x is equal to sum of x by 200 expression of minus x is equal to 400 x greater than or equal to 0 0 x greater than 0. Now what is the probability that the system will not last a full week? What is the probability that the system lifetime will exceed 1 year? Now we're discussing the state and prove bias theorem, differentiate, joint, and conditional probability. Short answer questions are define probability mass function, define variance of random variable, define total probability theorem, define central limit theorem, define the concept of random process, explain the movement about the origin and the mean, explain the exponential probability density function with valid plots. Now we're discussing these answers and how to study. Before that, we have to read the questions only. What are the important questions? Those are. Now we have to discuss about the sum of those questions answers. Now I have discussed the first question. State and prove the properties of probability density distribution function, the random variable x. Now the question answer is, if x is a discrete random variable, the distribution function fx of x is a cumulative sum of probabilities of x upon to the value x. As x is discrete, fx of x must have a staircase form with step functions. The amplitude of the step is equal to the probability of x at that x value. If the value of x are bracket of flower bracket of xi, flower bracket closed, the distribution function can be written mathematically as f capital X of x small x is equal to summation of 1 I is equal to 1 to n p of xi mu x minus xi. Here where mu x is equal to summation 1 to 1, here x greater than or equal to 0 and 0 less than or equal to x less than or equal to 0. This is unit step function and n is equal to number of elements in x. N may be infinite. Here for example, the experiment tossing 3 fair coins explained before the distribution function. For example, experiment tossing 3 fair coins explained before the distribution function. Now fx of x px 1 u x minus x plus px2 mu x minus x2 plus px3 mu x minus x3 plus px4 mu x minus x4. Fx of x is equal to 1 by 8 mu x plus 3 mu x minus 1 plus 3 mu x minus 2 plus mu x minus 3. Let fx of x be a probability function of x, a continuous random variable. The distribution function for x is given by fx of x is equal to integration minus infinity to x fx of x dx. Here 0 less than or equal to x less than or equal to 12 be a probability function of x in term in the continuous sample space 0 less than or equal to x less than or equal to 12. The distribution function fx of x is fx of x is equal to integration of minus infinity to infinity fx of x dx is equal to integration of minus infinity to x fx of x is equal to integration of minus infinity to x. Here f of x is nothing but 12 1 by 12 dx. Here fx of x is equal to x by 12 0 less than or equal to x less than or equal to minus 12 fx of x is equal to 1 for x less than or equal to, here x is greater than or equal to 12, the distribution function fx of x. The distribution function fx of x, this is the plotting of this value distribution function of x, nothing but x axis. This is the plotting of unit, this is the impulse function. Now impulse function like this, fx of x, this is the magnitude, this is the diagonal of this position point 1. Here fx of x is the value 1, and for which is less greater than or equal to 12. Now this value 12 like this is diagonal like this is plotting of random variable. Now we discuss the properties of probability distribution function. If fx of x is a probability distribution function of a random variable x, then fx minus infinity is equal to 0. We know that the probability of an event is a non-negative real number in the range 0 and 1. The probability from an impossible event is always 0. We know that the impulse event never 0. That is, x is equal to minus infinity. Here fx of minus infinity is equal to p of minus infinity, which is 0. Here fx of infinity is equal to 1, nothing but here fx of infinity represents the integration of all probabilities up to x is equal to infinity. That is, the sum of all probabilities of x is in given sample space, which is equal to 1, which is nothing but fx infinity is equal to summation of x is equal to minus infinity to infinity p of x is equal to 1. This is the first proof of first property of probability distribution function. Fx minus infinity is equal to 0, here fx infinity is equal to 1. Here now discuss the third property. Here 0 less than or equal to fx less than or equal to 1. Since the distribution function takes the value of all probabilities, the range of the distribution function is also the same as the range of probability. So 0 less than or equal to fx of x less than or equal to 1. This is the third property of probability distribution function. Now we have to discuss the fourth property is fx of xi less than or equal to fx of x2. Here fx1 is less than x2. Fx of x is a non-decreasing function of x, since the distribution function is a sum of all non-negative probabilities of f less than or equal to x. If x increases, then fx of x also increases. That is, the distribution function is a monotonically increasing function between 0 and 1. Here, the fifth property is nothing but p of xi less than or equal to x less than or equal to x2 is equal to fx of x2 minus of fx x1. This is known that prevents x less than or equal to x1 on x less than or equal to x1, and x1 less than x less than x2 are mutually exclusive. So the probability of the event p of x less than x2 is equal to p of x less than x1 union p of x close flower bracket open, x1 less than x less than or equal to x2, this flower bracket close, p of x less than x2 is equal to p of x less than x1 plus p of x1 less than x less than or equal to x2. Here p of x1 less than x less than or equal to x2, p of x less than or equal to x2 minus p of x minus less than or equal to x1, p of x1 less than or equal to x 2 is equal to fx of x2 minus fx of x1. Also, if x2 is infinite and x1 is equal to x, then x1 is equal to x2, then we have to see there p of over x greater than equal to x, fx of infinity minus fx of x is equal to 1 minus of fx of x. This is the fifth property of probability distribution function. This is the last and the sixth property, fx of x power positive plus is equal to fx of x. It states that the probability distribution function is continuous from x to x plus, where x plus is an infinite semi small increment in x, infinite small increment in x. Okay friends, this is the properties of